I'm Kat with the Boulder Watershed Collective. Very happy to have you here today. Woo! Local watershed groups, yeah! Thanks again, everybody, for coming. I am delighted to introduce Sarah Marshall, who will be talking about the Colorado state of the beaver. All right, turning it over. Thanks.
Thank you, Kat. And thanks for all coming indoors on this beautiful day to hear me talk. I'm going to be sharing some work that we've done in Colorado and across the West, mapping and modeling beaver ponds. So a quick overview of what this project was about. We started off with this challenge of tracking not only beavers and beaver wetlands, but wetlands in general across a part of the country where we have issues with droughts and aridification, also a lot of impetus to do restoration work, but things like policy change as well. And we were feeling like we just couldn't keep up with the beavers in terms of our mapping. And a lot of our mapping was on the order of 40 years old. So what we currently see today may be very different from what was mapped in the 1970s and 80s. So working with a team from Lynker, we set about to address this, tracking not only the extent of vegetated wetlands, but also surface water and then beaver ponds across the basin. And we began with an approach involving machine learning, but this involved a lot of human input as well. And just to show you our study area, again, we worked across the entire US portion of the Colorado River Basin, and then the entire state of Colorado. And we're not just looking at a single year, we're looking across approximately the last decade. So just as an example of what we previously had to work with, the National Wetland Inventory is one of the most comprehensive wetland data sets in the world, really. But again, it's a lot of work to do mapping like that, and a lot of it's pretty old. We've never had a beaver map, even for the state of Colorado, even within a 2 to 5 year period. And a lot of times what that looks like is this is the Colorado River headwaters, and you can see what was an active beaver complex. This is still what I would call a beaver wetland, but there haven't been ponds in more than a decade. So this is an area that was affected by the East Troublesome Fire, and as we're dealing with things like fires, we want to know where have beavers actually been active versus something like this that's kind of filled in with sediment and vegetation over time. We've also had things like the Beaver Restoration Assessment tool, which again is a really helpful tool, but doesn't necessarily tell us where the actual beavers have been. And for a lot of the Colorado River Basin in particular, including the entire state of Arizona, there was no beaver mapping. So we set out to fix that. And just to give you an example of kind of the hodgepodge of wetland mapping we had to work with, so the gray and white areas on this map are mapping from the 1970s and 80s. So that's a lot of the basin in states like Colorado, Wyoming, and Utah. And then as we work toward the darker blue colors, that's more recent mapping. Now these pink areas are where we mapped a lot of beaver activity. So you're seeing that essentially where the beavers are, the wetland mapping is old. So we wanted to fix that. And I probably don't have to tell this room why this matters, but we're banking a lot on beavers in everything from our state water quality management plans to our climate planning, and it's kind of a problem that we don't know where they are. As Dr. Fairfax pointed out in her talk too, beavers are incredibly important for fire planning. So again, in these mountain watersheds, we really want to know where they are and also just where their habitats are persisting over time. So our project had 3 parts. We had 3 separate models, one for vegetated wetlands, one for surface water, so lakes, ponds, rivers, and then a model that was specific to beaver ponds. And an important piece of that equation is that we had people who have spent a lot of time in actual wetlands on the ground, not only training those models, but we did a really in-depth review of the model results, so we felt really confident in the data. And I'll show you in a little bit. all these data layers are being shared in public mappers so that people can start actually using them to help conserve and restore wetlands across Colorado and the Colorado River Basin. So here's just a general workflow. So the team from Lynker did a lot of this upfront imagery acquisition. This is not a small effort. This was many terabytes of data across the West. Again, we then trained the model to say, this is a beaver pond, this is not a beaver pond, as well as, this is a river, this is a vegetated wetland. After these initial models, we did a lot of GIS post-processing as well so that things look tidy and load nicely in our mapping tools. So this is what one of our training areas looks like. This is the Lake Fork in the San Juans. And again, we drew these nice little boxes around the beaver ponds to say to the model, this is a beaver pond, this is not a beaver pond. A couple of quick caveats, and you all are very beaver savvy folks and probably know that we probably missed some tiny ponds. This was really focused on larger beaver ponds that we can detect at about a 1 to 3,000 mapping scale. So on the order of about 10 meters by 10 meters. And we did not distinguish between currently active ponds versus historical ponds. There are ways to look at our data set to infer some of that information, but a lot of it really needs some on-the-ground reconnaissance. And this is what it all kind of looks like when we bring all those things together. So you can see there are ponds that are mapped in the lighter blue colors from 2013 through to the darker colors in 2021. And these colorful envelopes that I'll explain a little bit more later are kind of clusters of those beaver boxes. So when we start to look at them and we dissolve all those little boundaries, we start to see these beautiful beaver corridors in the mountains. And the neat thing that we can do with these beaver corridors, so this orange box here is that same area we were looking at, we can start to connect these areas across entire watersheds and landscapes. So this is just something we couldn't really do before with all that old beaver mapping. So what did this look like at the scale of the basin? I sometimes hesitate to give pond counts because, again, I would consider this a lower estimate. These are big ponds. But we picked up over 65,000 ponds for the basin. Our first round of modeling for Colorado alone, we had a much smaller number of ponds for the earlier imagery in 2019. So this marked a change in our process. We actually changed our modeling process a little bit in that second round and did a lot more manual review. So we picked up quite a few more ponds. And if anyone wants to check out the model results for the Colorado River Basin, I've included the QR code for the Colorado River Basin mapper. I see folks still taking photos. But this will have vegetated wetlands, surface water, and the latest beaver ponds, and we'll be adding more data to this mapper soon as well. So in Colorado, which has by far the most beaver ponds in the Colorado River Basin, we had between 70,000 and 102,000 beaver ponds for each model year. So 2013 was actually our peak beaver year for the state. And about 90% of those were in the Southern Rockies ecoregion, aka the mountains in Colorado. And we definitely had a few watersheds that really stood out as having very high beaver density. The highest was about 3.6 ponds per square kilometers. And that's the East Taylor watershed, if you're familiar with Crested Butte, Colorado. So beavers in ski towns. And one of the coolest parts, as a wetland mapper, was that we picked up a ton of areas that weren't captured by the older National Wetland Inventory. So 43% of our latest imagery ponds were outside of previously mapped beaver areas. And that's not just ponds, that's the entire beaver complex. So wet meadows, shrublands, anything touched by beaver. So we filled a lot of gaps in places like the headwaters of the Colorado River, even out on Colorado's western slope in some of these drier areas, but also in places like the Plains and even the Front Range metropolitan area. And one of the really interesting findings that has surprised me the most, when we looked at these most recent ponds, around 95% of them were in areas that we had mapped in those earlier imagery years. So that says to me that the beavers are kind of sticking around, or at least moving around within these habitat areas and not really going outside of them much. And I'll show you kind of what that looks like a little bit later on. We also found that about 95% of the 2021 ponds were within about 250 meters of a 2019 beaver area. So again, the beavers seem to be kind of shifting around within these beaver corridors, but not necessarily going miles away to new habitat or unoccupied habitat. And you can see all of this information in our new Colorado Beaver Activity Mapper, or KBAM, where you can look up things like Boulder, Colorado, and you can see the beaver activity that's been present in the last decade in the watershed you're standing in. And this includes not only our beaver work, but also older national wetland inventory mapping, so you can see previous beaver areas. We also include the Beaver Restoration Assessment Tool results for Colorado. And then we threw in land ownership and management so that people can look at things like opportunities for coexistence. So before we could display all this information, while this is a very colorful abstract, we figured people didn't want to look at that in the mapping tool. So we created these, what we call beaver activity areas. And these are clusters of beaver ponds that are no more than 20 meters apart. And then we buffered out by 30 meters to capture the broader beaver-influenced wetland and even areas where they might be foraging. And this is 2023 imagery. This is a nice beaver wetland. But with our data, you can track what it looked like in 2013, 2015, 17, 19, and 2021. So we can see how the wetland really changes over time in terms of where and how much surface water ponding we have. So I'm going to spend the rest of my talk going over a couple of applications. And I hope for folks who are not from Colorado, maybe this gives you some inspiration of just something you might want to do in your home state. This particular area is in North Park, Colorado, and this is a beaver megaplex where we have over 700 ponds. And this area has probably been active for decades, if not centuries. But our activity areas picked up all the beaver ponds over the last decade. But a really important piece here is this line. So you'll notice it's Forest Service land on the left. But as we go into private land on the right, we start to see that the beaver activity really diminishes. And so when I see something like this, maybe there's some opportunities to work with this landowner that's on the other side of the fence here, on some coexistence, for example. Or maybe you have an unwilling landowner at the time, and you might go somewhere else. This might not be the best place to try to reintroduce beavers right now. We also kind of looked at these beaver corridors over time and looked at the frequency that they had mapped ponds. So the areas that are in the darker red and orange color are areas that either had beaver ponds in all or most years. And as we get to the lighter and lighter kind of yellow and cream colors, these are areas that maybe had beavers once or twice in the last decade. And when you turn on the public land and private land layer, you can start to see why that might be. But you can also see some spots like this in-holding up here, where maybe you have a landowner that likes beavers or is fine with them. So this is all, I think, really helpful information when you're trying to, for example, plan large-scale restoration projects. This is an example that some of my friends from Ecometrics and Colorado Open Lands have worked on up near Kenosha Pass. And our beaver activity mapper shows that the last time there was a lot of beaver ponds in this area was in about 2013. And when we look a little bit closer, so this area you can measure in the tool, it's about a mile long. There were 98 beaver ponds in 2013, but it's been pretty quiet ever since. And importantly, this little riparian wetland area, you can see goes from being much wider, kind of in this lower part of the image, to much narrower up above. And that channel is incised, and the wetland has become drier. So fortunately, this is all on public land, and it's got good access for people and equipment. And so our friends who have done the restoration out there have seen beavers come back in, presumably from areas upstream. So yeah, just a case study of how you might use this tool to explore similar sites around the state. Another application is for coexistence. So this is Highway 9 up near Breckenridge. And this is an example of an area that had kind of repeated problems with beavers flooding the highway. And this is a pretty busy area. So they put in some beaver coexistence structures, and to my knowledge, they haven't had as many problems with the highway flooding. So, you know, this tool can be used to say, okay, beavers just keep coming back to this spot. We can either keep removing the sticks and material from the culverts, or maybe we actually do some consistence here because they're going to keep coming back. So I wanted to leave you with a few ideas to chew on from all this staring at beaver ponds. I know that there's a lot of wonderful momentum right now to do conservation and restoration work, and I'm thrilled about that. But there are still a lot of these beaver hotspots of sorts that are not actually protected. So I think there are a lot of opportunities to kind of zoom in on those sites and really fill habitat gaps between these persistent beaver areas. And that might mean conservation easements, that might mean coexistence structures, or all of the above. Also, this may sound simple, but if your restoration project is intended to involve beavers, I think it's so important to consider beaver activity in the area first. And there are so many other wonderful, models and data sets and things to work with, but I think we can learn a ton just from where beavers choose to be, and sometimes where they choose not to be over time. So I encourage you to start with the beavers. And finally, looking around these different restoration sites that have been really successful, a lot of them, kind of the threshold for where humans intervened was about a decade of beavers not being in the site. So I'd like to kind of pose the question for the group to think about just, is that a good threshold for where we might intervene in these mountain sites? And we'll be talking a little bit more about this topic in a panel discussion later. And finally, there's probably a lot of restoration potential in those older mapped beaver areas. Some of them might be too dry or no longer suitable, but again, we have a pretty large pool of areas that are good candidates for restoration. Right. Thank you.
Thanks so much, Sarah. That was great. We have a couple questions in the app. Remember, you can always put your Q&A in the app, and if we have any extra time, we can take questions from the audience. First question is, how effective would this specific model be in a state with abundant wetlands and tree cover like Michigan?
That's a good question. Tree cover is probably one of our biggest challenges in this kind of approach. Part of the reason we actually did a lot of manual addition was tree shadows, which look a lot like beaver ponds in many places. So I think that might be a little challenging. You may have to, for example, incorporate topography a little bit more. So there are a lot of ways that you can kind of play with your regional conditions to get a better model. But yeah, our model definitely struggled a little bit, particularly in narrower drainages with more incised channels and trees.
Thank you. Second question, can this model be used to estimate carrying capacity of beavers?
That's a complicated question. I think, if anything, doing this mapping effort has taught me that maybe the natural state of things is not necessarily wall-to-wall beavers all of the time. I think there's a lot more to do on the ground to understand how beavers are operating before we could get to something like carrying capacity. But things that I would consider as a wetland person are looking at the broader habitat and the fact that beavers create habitat for a lot of different organisms at all stages, whether it's a drains pond supporting shorebird habitat or beaver ponds supporting fish. Yeah, I think that's a complicated question, so I'm going to punt on that a little bit.
Circle back on that one.
Yes.
Is the Colorado Natural Heritage Program tracking moose and elk impacts to willows outside of Rocky Mountain National Park?
Good question. So not specifically associated with this project, but just about every time we go survey a wetland, for whether it's the National Wetland Condition Assessment or projects with some of our restoration partners, we are, at least to some degree, measuring the impacts of grazing, both wild ungulates and cattle.
Next up, we have a lot of questions, so I'm trying to blow through them. How can you filter out intentional versus unintentional abandonment of decade scales? Follow up, is the return interval related to elevation or length of growing season?
That's a very good question. So we are in the thick of doing a big analysis, looking at all kinds of factors like elevation and slope and aspen cover to try to start answering some of these questions. I think it really depends on the system. So for example, some of our steeper watersheds, beaver ponds can fill in with a lot of sediment and it turns into a different kind of wetland. That's fine. But yeah, TBD, we're doing a lot of analysis on that. And I'd love to chat more when we have more results.
Next time, next conference, cheers.
Yes.
Did your team perform field surveys to validate the model? If so, how often smaller beaver ponds fall through the gaps? Pond estimation error.
Good question. We probably could do even more work on this end. One challenging thing of working with kind of post imagery, so older imagery, is you're always going to be chasing that a little bit. Some of these areas where beavers are sticking around over time, we were able to verify a pond in the same location. But it is challenging, particularly for smaller beaver wetlands.
Where is the best source of information to find historic imagery, especially if on private land, since Google Earth usually does not go back that far?
Yeah, it really depends on your location. I mean, sometimes you can go to your local university map library and find that information. I'm sure folks in this room have even more info on that. But yeah, most places, at least in Colorado, you can find imagery dating back to the 1930s.
Thank you. It seems like this model could miss bank burrow beavers in rivers that have too much flow for a beaver dam. Are there any ideas for solving that?
Yeah, so this is definitely a model capturing the works of dam building beavers. So we are definitely missing those wonderful bank burrowing beavers if they're not building a dam. So this would be a low estimate of the activity of beavers.
Right. Some fairly open-ended ones, I guess. What type of federal funding? Just period. Just question mark.
So there are people in this room who are probably giving talks about this, but the Infrastructure and Jobs Act has been a huge boost of funding to a lot of our federal agencies in recent history. I know the BLM in particular is funding a lot of great work around the state. Try to think of, I mean, there are a lot of different funding sources, and often there's a bit of match between our state and federal programs, and sometimes federal money flowing through state programs. So it's kind of a complicated.
Creative. Yes. Creative. What was the type 1 and type 2 error rate on beaver ponds for the COBAM model?
Yeah, so I do not have those stats right here. I do know I have our recall for the model was between 95 and 98% by ecoregion. So that's how many of the, looking at both the true ponds that the model detected and then also looking at the ponds that the model missed that we manually added. So that's really high. I will say that, however, our precision was relatively low. So we get a lot of what's called false positive ponds. So those pesky tree shadows or buildings and cul-de-sacs and things like that. And so we made a call up front that we wanted to be as thorough as possible in getting the true ponds. So we basically accepted getting a lot of false ponds as well, and we have some ways of dealing with that.
All right, thank you. We shoved all the questions in there that we could. You'll have to follow up with Sarah later. Give her a little break, I guess, and then maybe. Yeah.
Thanks, Scott.
Thank you.